This video presentation discusses how to compute the length of a line using a function. The length of a line on a grid can be solved by the Pythagorean theorem, where the square of the hypotenuse is equal to the sum of the square of the sides. For example, a squared plus b squared equals c squared. Solving for c, I need to take the square root of a squared plus b squared. The coordinates of the line are defined by its endpoints in xy notation. In this example, point 1, x is equal to a 3. Right here it goes 1, 2, 3, and y is equal to a 7. For point 2, x is equal to 11 and y is equal to 13. The length of x for line A is measured from 3 to 11, and the length for y is measured 7 to 13. We can find the length of C by finding the square of A, adding it to the square of B. We can square a number by multiplying it by itself. We can then use the square root function from the math library to compute the square root of A squared plus B squared. In this example, I have the square root of 8 squared, 64, plus 6 squared, which is 36, so I'll end up with 100. Take the square root of 100, and that's equal to a 10. The lab assignment is asking you to compute the length of 4 lines using a function. I've given the coordinates for line 1, line 2, line 3, and line 4. The function that is to be created for the lab assignment is defined like this. I have double, this is my return data type. The name of the function is length of line, and then there's the 4 arguments, x1, y1, x2, and y2. Each one of them has to be defined with its data type followed by a comma. So I have double x1, comma, double y1, comma, double x2, comma, and double y2. The function should be placed after main. Since we're placing the function after main, I need to put in here a prototype, or also known as a declaration, a function declaration, that has to be done above main. That way the compiler will know how to use the length of line function. The other thing to notice is there is a semicolon at the end of our prototype or our declaration, but when I'm actually defining the function here, there's no semicolon because I have a block of code that belongs to length of line. Here's the code for main. Inside main, you need to ask for the values for x1, y1, and x2 and y2. So use a cout and cn statements. I need to include iostream for cout and cn, include cmath for square root using namespace standard. Then here's my function prototype. Int main, open curly brace and a close curly brace down here. I'm declaring all of my variables. This time I did them all on a single line because I did that just to save space. You might want to declare them all on a separate line. Cout, enter x1, y1, x2, y2 separated by spaces. I'm doing that so that I can use cn, just like this. Cn will read x1, and as long as there's a space between the value for x1 and y1, cn will then automatically go and pick up the next value and place it in y1. If there's another space, it'll put the next value in x2 and the next value in y2. We can then call the length of a line function with x1, y1, x2, and y2. Notice there's a comma between each argument right there. So here's length equals length of line. Length of line should compute the length of a line and return a double, which then can be stored into the variable length. We can use the cout statement to display the length of line. So then we can say cout, the length of line is, I want a space right here so that the numbers won't be shoved right next to the word is. This is going to be the numeric value that was stored here that we got from the function length of line. and ENDL to move the cursor down to the next line. The length of line function needs to determine the difference in the x and the difference in the y coordinates. Square the value for x and square the value for y, find the sum of the squares, and then get the square root. Here is the code for the length of line function. Double is my return data type, and I am going to be receiving x1, y1, x2, and y2. These will be local variables. I have defined some extra variables internal to the function, a, b, and c. So a is going to be the difference between the x coordinates. B is going to be the difference in the y coordinates. I'll square a by multiplying it by itself, square b by multiplying it by itself, add the two squares together, so I have the sum of the squares, and then use the square root function to get the square root of a squared plus b squared. Put that answer in C, and then return C. So the value that comes out is going to be stored into length. You should have all the information to create the program that uses a function to compute the length of a line using the xy coordinates for the endpoints of the line. All you need to do now is make it work, complete the lab report, and submit it. I hope you enjoy this one. I'll also end up learning how to use a function and seeing how it works.